So, good morning, dear students. Once again, we are back with a new topic, that is conic section. So, the name itself says conic section. So, when a cone is cut at different positions of a section plane, various curves, various shapes are obtained. They are called as conic section. So, let us say how you define conic sections. The section obtained by the intersection of right circular cone by a plane in different position relative to the axis of the cone are called as conic section. So we have a right circular cone. The axis and the base of the circle are perpendicular to one another. These are called as generator. A cone has infinite generator. This is the apex. Apex and the base of the circle are connected with generators. So you have got imaginary lines over here. So you have got imaginary generators and infinite number of generators over here. So when the section plane is cutting at different position, we get different sections, such as when the section plane is parallel to the base circle and perpendicular to the axis of the cone, then the section obtained is a circle. When the section plane is inclined to the axis and it cuts all the generators on one side of the apex, the section obtained is the ellipse, right? So that is how you define an ellipse. And similarly, when the section plane is inclined to the axis and it is parallel, when the section plane is inclined to the axis and it is parallel to one of its end generator, the section obtained is a parabola. Similarly, for hyperbola, you have the definition in such a way that it is parallel to the axis of the cone and it is the section which is obtained is called as an hyperbola, right? So here in this figure you can see when this is dismantled, when the top apex is removed and when the observer is looking from the top, in the top view the circle will be visible. Here it is cutting all the generators and the section plane is inclined, making certain angle, we'll see later on, and it is cutting both the generators, all the generators. That case you get ellipse. In different fashion, when the section plane is parallel to the generator, you get parabola and hyperbola likewise, right? So these are various sections that you obtain. So let us see another definition of conic section. So when the cone is looked from the front, you get a triangle. It is also called as isosceles triangle. So this is an isosceles triangle. You have got apex, you have got generators. They are also called as end generators. This is the base of circle. Here, when the section plane is inclined to the axis, this inclination is what? We can say beta. This inclination is inclination between the section plane and the base of circle. Then you have alpha. Alpha is the angle between the generator and the base of cone. Then we have theta. Theta is the angle between axis of the generator and the generator. Right? It is also called as semi-axis angle. Similarly, the angle between the end generator, this angle will be twice of theta. That is angle between the end generators. It is also called as apex angle or apex inclination. Then we have phi. Phi is the angle between the section plane and the axis of the cone. That is phi. Now if you talk about alpha, alpha is the angle between the generator and the base of the cone. So alpha could also be defined as it is 90 minus theta, alternate angles, right? So we have section plane, which is represented by dot dash chain line. Now here the section plane is cutting the generators and it is inclined to the axis. Now this inclination is angle beta. Beta is less than alpha. In that case, the section which is obtained is called as ellipse. We get ellipse, right? We get ellipse as a section. So this is the condition for ellipse. Second condition, when the section plane is parallel to the end generator. It is parallel to the end generator. So in that case, alpha is equal to beta. Alpha is equal to beta. So the section obtained is parabola. It is what? We get parabola. And the third condition, when the section plane is parallel to axis or it is making certain angle, that angle beta is greater than alpha. In that case, we get hyperbola, right? So these are certain conic sections that are obtained. And then we have a term called as eccentricity. Before to that, the conic may be defined as the locus of a point moving in a plane in such a way that the ratio of its distances from a fixed point and a fixed straight line is always constant. This fixed point is called as focus and the fixed line as directrix. So the ratio of the distance of point from the focus to the distance of the point from the directrix is called as eccentricity. So eccentricity is denoted by E, small e, that is distance of the point from the focus, that is the fixed point, to the distance of the point from the directrix. It is also called as fixed line. So when eccentricity is less than 1, that condition, it is ellipse. When the eccentricity is equal to 1, it is parabola. And when eccentricity is greater than 1, then it is hyperbola. Similarly, when the line is passing through the focus and is perpendicular to directrix, it is called as the axis. Ahead we will see in the next video when we talk about ellipse, what is major axis and minor axis. And the point at which the conic cuts the axis is called as the vertex. So what we have seen in today's video, we talked about conic section. We have seen various orientation of the section plane on the cone, how it cuts and how the sections are obtained. We have also seen a different terminology, various angles, and how come various sections are obtained when the section plane has different orientation with respect to the generators and with respect to the axis. What is eccentricity? For ellipse, parabola and hyperbola, what are eccentricities? I hope things are clear with this video. Thank you for watching.